Before we get started, make sure that you subscribe to this channel. That way, when I release more content like this, you'll get notified.
Welcome to Break Even by Claire Tayman from teachbiz.co.uk. Firstly, what is break even? Well, break even is the point where you are producing and selling goods to cover your costs. Break even is the point where you are not making a loss and not making a profit. And break even is the point where the total sales revenue line crosses the total cost line on a break even chart. We'll explore that in further detail later on in this PowerPoint. So how do we measure fixed and variable costs? Well, fixed costs do not change on output, so how much we produce and sell. Therefore, it doesn't matter how many we produce, how many we make, how many we sell. It doesn't make any difference. The fixed costs stay the same. However, variable costs change on output, so the more we make, the more the variable cost will be. Let's give you an example. So if I explain using cakes, what ingredients do I need to make one cake? Well, I need 30 grams of butter, which costs me 30p, one egg, which costs me 10p, 60 grams of flour, which costs me 60p, and 100 millilitres of milk, which costs me £1. Therefore, to make one cake would be £2. These are my variable costs. They will change depending on how many cakes I make. Let me give you a further example. So now that we've done one cake, let's have a look at how the variable costs, so the ingredients, would change if I made 3 cakes. So we'd need 30 grams of butter times 3, so 90 grams of butter. 30 pence times 3 is 90 pence. I then need 3 eggs, so 10 pence each times 3 is 30p. 60 grams of flour times 3, which is 180 grams, so 60 pence times 3 is £1.80. And then 100 millilitres of milk times 3, which is £1 times 3, equals £3. If we then add all of those up, that equals my total variable costs of £6. So these are the variable costs which you'll note change depending on how many cakes I make, and in our scenario it means 3 cakes. So what about the fixed costs? Remember that these are costs that do not change on output, so that's how many I make. Imagine our cake scenario again. I have to bake the cakes in the oven, and my industrial oven can bake up to 400 cakes at a time. So it costs me £300 to run my oven all day at 200 degrees. If I bake one cake, what will my fixed costs be? That's right, £300. If I bake 50 cakes, what will my fixed costs be? Again, £300. So as you can see, my fixed costs do not change depending on how many cakes I make. So let's look at the break-even calculations. First things first, I need to calculate my contribution per unit, and this is how much money each product is going to put in my pocket. The formula for contribution per unit is the selling price per unit minus the variable cost per unit. If I want to look at total contribution, this is how much money the total products I have sold are going to put in my pocket. The formula is total sales revenue minus the total variable costs. So with the contribution per unit, let's look at the cakes. Say that we are selling each cake for £5 each. Our variable costs per cake were £2, which we'd already calculated. I therefore take my £5, which is my selling price. I take off my variable cost per cake, which is £2, which gives me a contribution per unit, or so contribution per cake, of £3. If I wanted to calculate my total contribution, we'll use an example. Say we sell 100 cakes. I would take my total sales revenue, which is 100 cakes, multiplied by my selling price of £5, which would equal £500. I would then look at my total variable costs, which would be 100 cakes, multiplied by the £2, which is my variable cost per cake, which would equal £200. Therefore, I take my £500 total sales revenue, I minus my total variable costs, and that would equal £300. We've already calculated that my contribution per unit was £3, so another alternative to calculating total contribution is taking the number of cakes I've sold at 100 and multiplying it by my contribution per unit, which would then give me the same figure of £300. Now we need to calculate break even. So what costs have we not included yet? We've been talking about the variable costs, but we haven't talked about fixed costs. So the calculation for calculating break even is fixed costs divided by contribution per unit. Let's look at calculating our break even point for our cakes. We calculated our contribution per unit to be £3, which was the £5 selling price minus the £2 variable costs. Our fixed costs were the oven at £300. Therefore, our calculation is our fixed cost, £300, divided by our contribution per unit, £3, which would equal 100 units. We would therefore have to make and sell 100 cakes to cover all our costs. That would include fixed and variable. So let's complete a break-even table using our calculations based on the cakes we are making and selling. You can either copy down this table and then fill it in as we're going along, or you can copy down this table and do it in your own time and then check back on the PowerPoint to see how you've got on. This would be good practice as well as good revision. We know that it doesn't matter how many cakes you make, the oven cost will remain the same, so our fixed costs. So if I produce no cakes, I still have my fixed cost of 300 because I still have to put my oven on and have it on all day. If I then make 50 cakes, my fixed cost will still be £300. And as you'll see going up with the number of cakes made from 100 through to 350, my fixed costs remain the same at £300. Now have a look at the variable costs. My variable costs we know were £2 per cake. This is my ingredients. Therefore, if I don't make any cakes, so 0 units, I won't be using any ingredients, and therefore my variable cost will be 0. If I make 50 cakes, so 50 units, I multiply that by my £2, which is my ingredients per cake, which would then give me £100. I then look at my 100 cakes, multiply that by 2, which gives me £200, and so on for 200 cakes, 300 cakes, and 350 cakes. We then have a look at the total costs. Well, we know that total costs is fixed costs plus variable costs. Therefore, my total costs if I don't make any cakes are still £300 because I have to take into consideration the costs of my oven. I then look at the number of cakes that I've produced, for example, 50. My fixed cost are 300, my variable costs were 100, and therefore my total cost, you add up the 300 and the 100, which gives you 400 total costs. And we carry on doing this for the number of cakes we make until we reach the 350 cakes, which you'll note the fixed costs remain the same at 300, the variable costs are 700, which is the 350 multiplied by the £2 per cake, and then I add the 300 and the 700, which gives me the 1,000. Revenue. Well, I know that I'm selling each of my cakes for £5. Therefore, if I don't sell any cakes, so 0, I don't make any revenue. If I sell 50, I multiply 50 by £5, which gives me £250. I then do 100 times 5, 200 times 5, 300 times 5, and 350 times 5, and that will give me my figures down the right hand side, and this is my total sales revenue. Let's now see if we can plot these table onto a break-even chart. So looking at our graph, normally on the bottom I would use 0, 100, 200, 300 and 400 for our output, which is our units, so in our case the number of cakes. I've put in the 50 and the 350 as a guide. On the left hand side is costs and revenue, and that's where we will plot our costs and revenue. So that will be fixed costs, variable costs, total costs and our sales revenue. So let's first of all plot our fixed costs. We know from our table that the fixed costs were £300 no matter how many units we produce, and therefore the fixed costs line is a horizontal line. You'll notice as well where the 0 is that it goes up to 300 because even if we don't produce any cakes, we still have to turn our oven on, and therefore we still have to plot that at £300. Now let's plot the sales revenue. Here's our sales revenue line, and you'll notice that the lines going up towards the revenue line show quite clearly where our points are. So if we were to have a look back at our table, for example, we would notice that with regards to the 50 units, the revenue it was giving us was 250. So if you have a look at the total revenue line and draw it down following my black dotted line to the 50, you'll notice that's 250. Again, for the 100 units, we notice that it's 500, and you'll notice the black dotted line showing it down. You do not have to plot the black dotted lines. This is purely for me to show you how this works. Once we've plotted our fixed cost and our sales revenue, we can then plot our total costs. Now the total costs start at the fixed cost line, and I'll explain that in a little while. But again, you'll notice that we plot these lines from our table, and it shows quite clearly where we're fitting. So for example, the total cost with 50 units, if we look back at our table, was in fact 400, and you'll see that that looks right on our chart. We can then plot the variable costs, and again the variable costs are a direct link to our table. We're simply finding 50 units and working our way up, as well as 100, 200, 300 and 350. On our graph, you have plotted the total cost and variable costs, and you'll notice that the total cost line and variable cost lines are parallel. You will also have noticed that the total cost line does not start at 0. This is because the formula for total costs is the variable cost plus fixed costs. Remember, we said that fixed costs do not vary with output. Therefore, in our situation, the oven is turned on at £300. So even if you do not put any cakes in the oven, our fixed cost will still be £300. If you're adding the variable costs onto the fixed costs, then our total cost can't possibly be below £300. So if, for example, we were to make 0 cakes, you would not have 0 fixed costs. They would still be £300. And this is why we plot our total cost line starting at the fixed cost line. So now what we need to do is mark up the break-even point. Remember, the break-even point is where the sales revenue line crosses the total cost line. So where our break-even point is, where the black arrow is pointing, is where those two lines cross. We then can draw a dotted line down to our units line, which shows us how many units we need to produce and sell to break even. And in our diagram, we can see that it equals 100 units. So does this match up with the calculation? So the break-even point is saying on our graph that it's 100 units. So in our case, we need to make and sell 100 cakes to break even. That's covering all our costs. Does this match with our calculation we did? Well, if we look at the calculation, it's fixed cost divided by contribution per unit. So £300 divided by 3 equals 100 units. So yes, our graph is accurate and very well done. So now we need to calculate the margin of safety. So now the graph is drawn and we know break even is 100 units, we now want to look at trying to calculate the margin of safety. The margin of safety is the gap between what we actually sell and the break even point. So we know from our graph and our calculations that break even is 100 cakes. If we were to sell 300 cakes, then our margin of safety would be calculated as 300 cakes we've sold minus the 100 for break even would give us 200 cakes. So let's plot that on our graph. As you can see, the green shaded area is marked as the margin of safety. So I've drawn a line from the 300 units up to the sales revenue line, and then I've coloured it in going back from the 300 units to our break-even point of 100 units. So that shaded area is known as our margin of safety. Advantages of using break-even. So we all know how many customers you need to have or items you need to sell to break even. In our case, it was 100 cakes. Break even can also inform decisions about what price to charge, and then we can move this up and down on our graph depending on how much revenue we are making. You can use it to set targets for the business and for any staff you may have. So if you want to set the number of items they need to make per person, as long as you're targeting over the break-even amount, then you're likely to start making a profit. In our case, it would be 101 cakes, at which point we would start making a profit. It also allows you to identify your fixed and your variable costs. You can identify if costs are too high and take action to lower them. For example, in our case, if our ingredients were too high and it was too expensive, for example, for our milk, we may try and look for alternative suppliers to provide us with milk at a lower cost. It is also a simple way of calculating profit and loss at different levels of output. So if we were to have a look at our graph, for example, you could have a look at 200 units and see how much revenue that was going to be making. We would then be looking at the profit. It allows for what-if scenarios. For example, what if I was to increase the selling price? I would then recalculate my sales revenue, replot it on my graph, and then I could work out what my break-even point was. If I don't want to plot it on a graph, I can use the calculations in my PowerPoint that I have learnt, and that will be able to enable me to calculate break-even. It also identifies the margin of safety, so you know how many units sales can fall by without making a loss, and no business wants to make a loss. So let's now have a look at the disadvantages of using break-even. Well, break-even theory only applies to one product. So in our case, it just applies to one, for example, chocolate cake. If, however, you want to include making croissants and those sorts of things, you would have to have a separate product because it would have a separate selling price and it would have separate variable costs. It assumes that all the products made and bought can be sold. It also assumes that all products are bought and sold at the same price. So again, you would need to have a look at your calculations. So if you were going to be, for example, introducing croissants or bread, there would be different variable cost prices and there would also be different sales prices, and you'd have to calculate all of those and redo your break even. It also assumes that fixed costs will stay fixed regardless of output, which may not be the case. For example, if you have an oven which you can put 400 cakes in, but you want to run 2 ovens because you have 800 cakes, then the fixed cost will change because, of course, your oven cannot accommodate 800 cakes. It also assumes that variable cost per unit stays the same. And again, this will vary depending on the product you are making and also the cost of those ingredients. And also break-even is only a prediction. We may not know exactly how many products we're going to sell, and therefore it's not 100% accurate, but it does give us a good idea of what products we need to produce, how many, what we need to sell them for in order to make sure that we are covering all of our costs. So let's have a look at testing your formula knowledge then. Are you ready? If you write down numbers 1 to 6, and then you need to write down the answers to each of the formula that appear on the screen. So let's start. Number 1, what is total sales revenue? It's the sales price multiplied by the number of units sold. Number 2, contribution per unit. Sales price minus variable cost per unit. Number 3, total variable costs, which is the variable cost per unit multiplied by the number of units you've produced. Number 4, total contribution. There are 2 answers here, either contribution per unit multiplied by the total number sold or the total sales revenue minus the total variable costs. Either of those will give you the total contribution. Break even is the fixed costs divided by the contribution per unit. And the last one, number 6, margin of safety, which is the actual sales, so the number of units you've actually sold minus the break even. And hopefully you got all of those right. If you didn't, then go back over this PowerPoint and see where you went wrong, and then have another practice at this test your formula knowledge. I hope my break-even PowerPoint has been relatively easy to follow and that you have been able to use the calculations correctly. Feel free at any time to go back to the PowerPoint, to the video, and just have a look at the parts that you're unsure of. When you're looking at BTEC qualifications, especially with regards to Unit 3, with regards to break-even, there will always be an exam question following on from the break-even. For example, Sarah has been running her business Live for Health for 12 months now, and she is worried about the current financial position. Despite identifying a niche in the market for organic health foods, her financial forecast had indicated that her business would be profitable by now, especially given the long hours she has put into making the business work. Analyse the usefulness of a technique like break-even analysis to Sarah's business Live for Health, and this would normally be 8 marks. So you need to pick out the points you will refer to in your answer, because it's very important when answering questions like this that you will need to contextualise. That means using information from the question. So Sarah has been running her business Live for Health for 12 months. So we know with that 12 months that it's a relatively new business. Despite identifying a niche in the market for organic health foods, her financial forecast had indicated that her business would be profitable by now. So again, she is expecting to be making a profit. And we've highlighted that because that is something that you would refer to in your answer. So how do you start? You need to show your knowledge and you also need to contextualise, so use the information from the question. You also need to be using linked words or connectives, things like this means and therefore. So an example of a paragraph you could start with for a benefit. One benefit to Sarah of using break-even analysis is that it can help to identify if the costs of the business are too high, particularly important for a new business like Live for Health. You'll notice there that we've picked out the costs, so we're showing our knowledge. We've also picked out the fact that it's a new business, and that shows that we're contextualising. We then use a connective. This means that Sarah can take appropriate action to reduce them and help the business to reach its break-even point much faster. For example, high advertising costs are common in a new business and, using another connective, therefore, Sarah may be able to look at alternatives in order to lower them. As Live for Health is in its early stage of development, 12 months old, again contextualising, it is likely that Sarah may have underestimated initial costs like advertising her new business, which has led to a delay in her reaching the break-even point. So now that you have discussed a benefit, you now need to discuss a drawback or disadvantage. So one drawback to Sarah of using break-even analysis is that it assumes that the product is sold and doesn't take into account any stock left on the shelf. This means that Sarah may need to increase her sales to ensure that all the products bought, generate sales revenue, which in turn would improve Sarah's financial position and help her to meet and exceed break-even quicker, which would then help her to make a profit. So not only are you giving a disadvantage, but you're also relating it back to the question where it was saying that she was expecting to make a profit by now. With an 8-mark question such as this, you want to be putting in a minimum of between 3 and 4 benefits and disadvantages, and do then come to a conclusion as to whether she should or shouldn't be using break-even analysis. I hope that my PowerPoint has helped you learn or improve your knowledge of break-even, and that the question at the end gave an indication of the sort of question you may get in the exam. Please bear in mind that break-even may not necessarily be in the exam, but it's always good to have in your knowledge bank just in case. I hope that you've liked this video, so please like it and then subscribe for future videos coming up. Thank you very much for your time.